connected. First, let's focus on the Y connected source. So let's label the lines as line A or phase A, phase B, and phase C. So a Y connected source is connected in this configuration. So the voltages here, this voltage sources here, are what we call the phase voltages. So they are connected in a common line. Let's label this as N, or a neutral line. So a Y connected source can either be 3 wire or 4 wire. We have N. So for this case, this voltage source right here is labeled as VAN. So we have this source right here, VN. Source at the bottom is labeled as VEN. So these are the phase voltages. So VAN, VBN, and VCN. So what are the values of these voltages? So for a balanced three-phase voltage source, the magnitude of this voltage source is equal, but they are 120 degrees out of phase from each other. What we have seen from the previous slides. So depending on the uh, rotation of the generator, so we have a positive sequence. Let's first talk about positive sequence. So let's make VAN as our reference. So let's say VAN has a magnitude of VP angle 0. If it is positive sequence, VBN has the same magnitude, but it is lagging by 120 degrees from VAN. And then VCN, it is lagging by 120 degrees from VBN. So we have negative 240 degrees. Or it's just the same as uh, leading VAN by 120 degrees. So those are the phase voltages for a positive sequence. Now, for balanced three-phase source, we also have line voltages. So if you look at this figure right here, so a line voltage is a voltage between two lines. So voltage between two lines. We have a voltage between AB, a voltage between BC, and then we have a voltage between CA. So a voltage between AB, we label this as positive, negative, and then VAB, and then the voltage between VBC is, we have positive, negative, VBC, and then the voltage between C and A, we have plus minus VCA. So these voltages here are the line voltages. So we have VAB, VBC, and VCA. So what are the values of these line voltages. So what are the values of these line voltages? So if you take a look at this loop 1, we have VAB, which is equivalent to VAN minus VBN. And then substituting the values for VAN and VBN. So we have VAN is equivalent to VP, magnitude VP with angle 0, minus VBN is VP with angle negative 120. So if you factor out VP here, then we have 1 angle 0 minus 1 angle negative 120. So this is equivalent to negative 3 VP angle 30 degrees. Now if we solve for BBC, it's just similar in solving VAB. We have VBC is just VBN minus VCN, and then VCA is just VCN minus VAN. So following this uh, step, we get the value of VBC as square root of 3 VP angle negative 90, and VCA is equivalent to negative 3, square root of 3 times VP with angle of positive 150. So if we take a look at these values right here, and these values right here, so let's rewrite them side by side. If we take a look at the relationship between the phase voltage and the line voltage, we have the line voltage is just equivalent to the magnitude of VP times square root of 3, and you add 30 of the angle. You look right here, magnitude of VAN multiplied by square root of 3, and then the angle just added by 30. So same with here, angle is added by 30, and right here, the angle is added by 30. If you're given the phase voltages, you can use the shortcut to find the line voltages, or you can use KVL like what we did right here. So when getting a line voltage from the phase voltage, we have VL, the line voltage is just equivalent to square root of 3 times the phase voltage, then you add 30 to the angle. So drawing the Phasor diagram of the phase voltages and line voltages. So take a look at this diagram. We have here is VAN. So 180 degrees here is VBN. Another 100 degrees, 120 degrees. So this is VCN. This angle right here is 120. Also 20. This is 120. So the line voltages are created here. So if you take a look at these angles between line voltages, so this is still 120 degrees, 120 degrees, and then 120. Now that all was for the positive sequence. Now for the negative sequence, the difference is that the phase voltages, so let's have VAN as our reference, still our reference. So the difference is that VBN is now leading VAN by 120 degrees, and VCN, now the one is lagging by 120 degrees.